So in this lecture, we'll talk about invertible functions. Invertible functions are functions for which we can find an inverse. So if there's a function that is invertible, it would mean that we can find a mapping from, so it has a mapping from A to B, then if it's invertible, there should exist a mapping from B to A. So in general, a function may not be invertible. But if the function is one-to-one, so we talked about one-to-one and onto functions in the previous lectures. So if a function is one-to-one and onto, then its inverse exists, right? So it's an invertible function if and only if it is both one-to-one and onto. So now a question for you guys: which of these function is invertible? So again, looking at the two conditions that I mentioned, what do you think, which of these functions is an invertible function? So pause the video and think about it. Okay, so let's look at each function one by one. So we have f1, f2, f3, and f4. So you can see f1 is one-to-one. A maps to 4, B maps to 1, C maps to 2, right? But there's no mapping of 3. Right, so it's one-to-one, but it's not onto because 3 is left over. Okay, let's look at f2 now. F2, you can see is one-to-one. One element goes to a single element, so that's one-to-one, and onto nothing is left over. So it's one-to-one and onto. So f2 is therefore invertible. Let's look at this. F3 is not one-to-one because you can see that R goes to V, U goes to V. So two elements are mapping onto a single element, so it's not one-to-one, but it's onto because nothing is left over. And F4 is neither one-to-one nor onto, so its inverse definitely does not exist. So F2 is the only function that is invertible amongst these functions. So the invertible, to get the inverse mapping, you just have to invert the arrow. So oops, sorry about that. So you just have to reverse the arrows. You do like this, right? So that's why this function is invertible, because you just have to reverse the mapping, and the properties are retained, that it's one-to-one and onto. And here's an example of why that's important. So let's say that you have a function, right, that maps x to y. So you can see that we have a mapping for that takes 1 to 7, 2 to 9, and 3 to 9, and 8 is left over. So now you can see that it's neither one-to-one nor onto, okay, because 2 elements are mapping onto a single element, so it's not one-to-one, and 8 is left over, so it's not onto. So now if we try to invert the mapping by when we invert the mapping, see, we're just going to write the so this is like mapping from y to x, and this is a mapping from x to y. So now if you invert the arrows, such that 7 goes to 1, and then 9 goes to 2, and then 9 goes to 3 as well, as you can see over here. So now this actually violates the definition of a function as well, that you can see that a single element is mapping on to 2 elements. So this is not a function. As we have discussed, if a single element maps onto 2 elements, then it's not even a function. So therefore, its inverse does not exist, right? F does not have an inverse. So here's another example. We have a one-to-one function. You can see it's one-to-one and it's onto also. So in this case, the mapping G inverse of y to x, right? So this is G inverse, right? You can see that we just reverse the arrows, right? And then you write y first. This is y and this is x. So this is completely fine, right? It doesn't. It is when you reverse it, it's still one-to-one onto, and it's a function as well. So the inverse of this function exists. So the way to write the inverse elements, right? So G inverse, this value 7 corresponds to 2, as you can see over here. Also, 8 corresponds to 3. And 9 corresponds to 1. Okay, and so this is how you write the inverse mapping. Now, how do you find the inverse of a function? So this is again a function. So R again represents the real numbers, right? A set of real numbers, and this is a mapping from a set of real numbers to the set of real numbers, and this is the function f of x. Now, how do you find the inverse of a function? The steps are fairly simple. So now the f is 1 to 1 and onto, and the way you can find the inverse is that you set 3x minus 2 equals y, right? And then you have to solve for x. Okay, so now if you add 2 on both sides and divide by 3, you get x equals y plus 2 divided by 3. And so the inverse, so this is just going to be the inverse of the function x. Again, what you do is you set the function. So this is our function 3x minus 2. So you set the function 3x minus 2 equals to y, and then solve for x. So when you solve for x, whatever you get is going to be the inverse of the function. And I'm just gonna post a video that in which I'm gonna discuss the method on how to prove that a function, a simple method on how to prove that a function is 1 to 1 and onto.